Welcome to Spring LIB.
Okay, so we simply must show that the superposition of these two functions, there are solutions to the Schrödinger time dependent. Therefore, a superposition psi of x and t should be described as A of psi of x and t 1, because it's the first function, plus B psi of x and t 2. Okay, so that's the superposition psi, and we must show that this function psi here is a solution to the Schrödinger's time-dependent equation. Well, let's remember that the Schrödinger time-dependent equation is negative h squared to m, the second derivative with respect with position of psi of x and t, that is equal I h d dt, sorry, psi of x and t. So that's the equation we must solve to prove that this function psi in here is also a solution to the Schrödinger's equation. Therefore, let's move on. We have in here negative h squared to m. This is the second partial derivative with respect position of a psi 1 plus b psi 2, that is equal I h d dt of a psi 1 plus b psi 2. Okay, therefore we know that partial derivative can be distributed between these two functions, is additive, is an identity. Therefore, this is negative h squared divided by 2m, and here we have the partial second derivative with respect position of a psi 1 plus the partial second derivative with respect position of b psi 2, close brace, that is equal I h open brace d dt of a psi 1 plus d dt b psi 2, close brace. Well, if we rearrange these equations here, we can say that negative h squared divided by 2m of d2 dx2 psi 1 minus I h d dt psi 1, all this being multiplied by the constant a, should be equal the constant b that multiplies negative h squared to m d squared dx squared psi 2 minus I h d dt, sorry, this is a plus, and this is a plus also, plus I h d dt of psi 2. Well, the problem says that psi 1 is a solution of the time-dependent Schrödinger equation, and psi2 is also a solution. Therefore, we can state that this is equals 0 because of that argument, and this is also equals 0 because of that argument. Therefore, since we have here the left equation equals 0 equals the right equation equals 0, that means that the superposition of two waves also satisfies Schrödinger's time-dependent equation. Okay? And that's the final answer. Thanks for watching.